All right, good morning, everybody. Thanks for starting day 2 at Build With Us at BRK260. Today we'll be talking about how you can build local AI-powered apps for the over 1 billion Windows devices out there. No need for a cloud setup, no token costs, and no network needed. All through a stack that's generally available and ready for your production workloads and powered with the latest innovation from across Microsoft and our silicon partners, AMD, Intel, NVIDIA, and Qualcomm. We also have several announcements and a ton of live demos lined up across 5 devices, so it's going to be quite something. So let's go ahead and get started. We are your speakers for this session. My name is Anastasia, and I'm a product manager at Microsoft working on Windows ML.
And my name is Aditi. I'm a product manager at Microsoft working on the AI APIs.
Awesome. So for those of you that attended the keynote yesterday, you'll have heard Satya talk about unmetered intelligence, or shifting from always running your AI workloads in the cloud to running them locally, using just the hardware on everyday PCs, and only going to the cloud when your workload truly needs it and it's worth the cost. And thanks to recent advancements in AI models, hardware, and the software stacks that run them, today every Windows PC is becoming increasingly AI capable, leveraging powerful GPUs for maximum performance and compute-intensive workloads, NPUs on Copilot Plus PCs for maximum power efficiency and always-on experiences, and even CPUs for maximum reach, especially with lighter weight workloads. But enough talking about it, let's take a look at some of the real-world examples of what developers are building using local AI through Foundry on Windows.
So you were telling me all those experiences are running AI models locally?
That's right, all local, no cloud setup. All right, so let's talk about why developers and enterprises are betting on local AI. From Adobe to WhatsApp, building some incredible local AI-powered experiences. The first is running models locally can help improve privacy and security because there's no customer or sensitive enterprise data that ever has to leave the device. Second, it reduces latency because there's no round trip that's needed to the cloud, and that's going to be particularly critical for real-time workloads. Third, it enables AI experiences without the need for a network connection because all of the compute is taking place right on the device. And finally, not all AI workloads need cloud scale, and running models locally can significantly cut down costs. And it's not just developers that are betting on local AI. Microsoft experiences are betting on it as well. From Outlook Summarize to GitHub Copilot, all built using the same stack that's being offered to developers and enterprises.
So how can developers get started building these AI-powered apps?
Yeah, I'm glad you asked. That's what Foundry on Windows is for. And that includes the Windows AI APIs, which are the turnkey APIs powered by Windows inbox models that you can use for common tasks such as natural language, vision, and many others. And these are generally going to be the easiest way for developers to get started building local AI-powered experiences on Windows. Then, for developers that are interested in using common open source models, they can run those locally using Foundry Local, which has a range of models that have already been pre-optimized to run really well across all Windows devices. And then you can use Windows ML to run your own custom model. This can be one that you trained yourself or found on Hugging Face and then fine-tuned for your scenario. And Windows ML is also the underlying backbone that powers the entire Foundry on Windows stack, enabling its core cross-silicon capabilities. All right, now it's time to introduce our demo scenario, the Unmetered Token Cafe, which is powered by Foundry on Windows, where the coffee is great and cloud token costs are a thing of the past. So this cafe just opened. Like any small business, the owners are wearing every hat, doing everything from taking customer orders to running their experimental brews program. They don't have the budget for cloud AI bills. They don't want to have to rely on their flaky cafe network for all of their business operations, and they need all of their workloads to just work using the PCs that they already own. All right, so throughout the rest of the session, we're going to be enabling various local AI-powered experiences for this cafe through Foundry on Windows. But as you can imagine, the possibilities are really limitless in terms of how you can use Foundry on Windows and local AI for your own apps and enterprise workflows. So to get started, Aditi, what would be the best way for the cafe to enable customer orders?
Great question. Well, the cafe has a drive-through, and customers drive up, they speak their order into the microphone, and we need to convert their spoken order into text. And the easiest way to get started with this is through the Windows AI APIs. So today, I'm going to demo to you my sample drive-through application. I'm going to be running this on my Microsoft Surface device with a Qualcomm Snapdragon NPU. Alrighty, so here is my drive-through application. And let's say a customer rolls up. They're going to hit that press to talk button, speak into the microphone, and say their order. In the backend, this is going to use our brand new speech recognition API to convert their spoken order into a string, into text. So Anastasia, tell me, what would you like to order today?
Yeah, I think I would like to get a matcha latte. I would want to get it with soy milk, extra hot because I'm always cold, and then maybe a croissant on the side as well.
And there we go. Here is Anastasia's order, outputted by our new speech recognition API. So this particular API took input from the microphone, but it can also take input from audio files and audio streams, like if you were trying to enable a calls or meeting type of scenario.
So that demo, though, that was running on the NPU, right? But what about the devices at the cafe that might not be Copilot Plus PCs? Would they still be able to run the workload?
Yeah, the really great thing about this API is it runs best on Copilot Plus PCs. It uses the NPU, but it also works for CPU. Now, when we first released the AI APIs, we released them for the NPU. But we heard so much customer feedback that you would all like to address a much broader hardware spectrum, and we hear you. So today, we're super excited to share that we're expanding the support of many of the AI APIs to run on CPUs and to run on GPUs. So you can reach a broader set of devices, a broader set of customers with these APIs. So for my next demo, I'm going to show you 𝗲𝗲𝗀𝗀𝗀, our small language model, newly running on GPU. OK, so all of those orders that we took in through the speech-to-text API, well, they're sitting in an unstructured text in a barista queue. And we want someone looking at this queue to really easily be able to understand what they need to do. So here I have my ordering application, and a barista is going to take a look at this and maybe hit one of these orders. In the back end, this is going to use 𝗲𝗲𝗀𝗀𝗀 running on GPU. It's going to extract all the relevant information and structure its output as JSON, which again is using a new API for structuring 𝗲𝗲𝗀𝗀𝗀 output. If you can see on the task manager, there's a little spike on GPU because it's all running locally on the GPU. And here is the JSON output that I wanted from the language model. And you can see this is the drink I want, the size, the modifiers, quantities, everything. Really quick glance, you know what you're making. And how I implemented this, actually pretty straightforward to use the AI APIs. It's just a few lines of code. All of our APIs use a very similar calling pattern. So first, I'm going to check if the model is ready on the device by calling this getReadyState function. If it's not ready, I call ensureReadyAsync, which is going to install it. Then next step is initialize the model with create async. And then the very last step is generating a response from the model. Here I've done a little bit of fancier work with defining the JSON schema that I want, but I just call this generate structured JSON response. And there you have it, really easy to use the Windows AI APIs. We already have production experiences that are using 𝗲𝗀𝗀𝗀 on GPU. For example, if you've used the summarize feature in Outlook, that uses 𝗲 on GPU. Now let's take a broader look at the set of AI APIs that are available today. Starting on the top left, we have our task-specific APIs. Many of these are already generally available. These are things like image description, conversation summary, text to table. But we know that real scenarios sometimes need more customization. And that's where our customization APIs come in. This is fine-tuning the language model with LoRa adapters, doing app content search, or RAG, and structuring your language model output. On the top right, we have our media APIs. This is video super resolution and speech recognition. So that enables audio-video features for you. And then on the bottom corner, we have imaging APIs. This is a growing set of imaging APIs. And you can take these, apply them to any domain, accessibility, productivity, enterprise workflows, you name it. And just to give you a glimpse, these are the APIs that we have now expanded to run on GPUs and CPUs. All right, so we already have a ton of ISVs that are using the AI APIs. But today, we're really excited to have Alfred from Clipchamp with us to show us video super resolution. And he's going to be demoing this on an ASUS device with the AMD NPU.
Thanks, Aditi. Hello, everyone. I'm Alfred from Microsoft Clipchamp, the free video editor built into Windows. In Clipchamp, we want video creation to be simple and accessible for everyone. A common part of editing is using clips from different sources like phones, old videos, and screen recordings. But those clips may not match the final export resolution, making parts of the video look soft or blurry. This is where Video Super Resolution, or VSR, can help. It uses AI to upscale a video and add details that simple resizing cannot. We are adding this local model into Clipchamp, so users can do this without leaving the editor. The flow is simple. Select a video, open the upscale panel, choose a resolution, then click upscale. When it's running, let me switch to the code and show how we integrate VSR. We start by making sure that the model is ready. Then we create a video scaler instance. With the scaler ready, here's how we upscale each frame. This method receives a decoder frame from the pipeline, along with an output surface. We pass both to scale, and out comes the upscale frame. Finally, the encoder can turn them back into a video, as simple as that. The upscale should be done, and yep, oh wait, it's still, oh yeah, there we go, it's done. Here's a quick comparison video. Watch the face, it looks much sharper on the right. It's pretty cool, right? And here's the best part. VSR can run on both CPU and NPU, so more Windows devices can use it, and NPU makes the experience even better. Anyone can get sharper videos inside Clipchamp and in your apps too. Now it's your turn. We can't wait to see what you can build with VSR. Thank you very much, and enjoy the rest of Microsoft Build.
Thank you, Alfred, for that demo. I know that at the cafe, they're definitely going to be using VSR, Clipchamp to make their marketing videos to help promote the cafe. Okay, so in the keynote, you might have heard Sathya talking about Ion, and you're wondering, how does Ion fit into our story? Well, Ion is going to be the successor to 𝗲𝗀𝗀𝗀𝗀, and it will be available via the AI APIs. But until then, you can go to that link and try it out for yourself, and we can give you a little sneak preview today. Okay, so if you remember Build last year, we showed the prompt API in the Edge browser. Today, this is being powered by Ion, and you can also try prompt API. Just toggle on a few flags in the Edge Canary. And so here I have a prompt, I have a system prompt, and I'm going to hit run. And this will generate a response right here on the side. There we go. Okay, so today with Ion, we are getting even bigger improvements in model quality, in context window, faster tokens per second. And this is going to level up the language model experience that you get with the AI APIs. And just like all of our other APIs, Ion is going to be in-box. So you don't need to handle any distribution. Windows is going to do it all for you. Okay, so now you have seen in-box APIs. But what if you want to run common open source models? Well, that is what Foundry Local is for. You might be familiar with Microsoft Foundry on Azure. Well, we have Foundry Local, which enables you to run common open source models on CPUs, GPUs, and NPUs. And now Foundry Local is in GA. So Anastasia, tell me, what is the next thing we should enable for the coffee shop?
Yeah, well, there are lots of customers like me that really like their matcha lattes. I want to make sure that the cafe never runs out. How should they implement maybe an inventory management system?
Yeah, they are getting a ton of demos. They're getting a ton of deliveries, and they need to easily take inventory of everything that's being dropped off. Delivery drivers are dropping stuff off daily, weekly, so we are going to use Foundry Local to power an inventory application. Okay, so I'm going to get started and kick off my inventory app. And here I will upload an image of all of my dropped off product. And once that model is loaded into memory, I'll hit identify items. In the back end, this is going to use the 𝗦𝗽𝗀𝗶𝗀𝗁 3.5 vision language model. It's brand new to the Foundry Local catalog. And it's going to classify everything, describe everything in that image, so it makes it really easy for me to know what I got and log the inventory. There we go. So I can show you in code how straightforward it is to use Foundry Local. In my experience, the best way to get started is go check out the GitHub repo. There's a ton of samples there, really easy jumping off point. So first, I call this getModel function. To that, I'm passing 𝗦𝗃.5, the 9 billion parameter variant that I want. Then step 2, I call model.download to download it to the device. Then I'm going to call model.load, load it into memory. Once it is loaded into memory, I will call create responses client. And then the last step is actually generating a response. So here I call create streaming, and I pass to it an input, which is my input image, and a prompt, you are a helpful coffee shop inventory assistant. And here we go. There's a description of everything that came in that image.
Phew, what a relief that I'm always going to be able to get my matcha latte at this cafe. And really cool that Foundry Local will take care of things like model management as well. Aditi, could you tell us a little bit more about how that all works and the tech behind Foundry Local?
Yeah, great question. Well, starting on the left, you have access to a rich model catalog. This is everything from open source GPT models to DeepSeek, Mistral, Qwen, Phi, even Whisper for speech scenarios. And today, what is net new? Well, we have new variants of Qwen, like that vision language model you saw, and there's new speech models too. And you can access all of these through the Foundry Local SDK, which abstracts away all the complexity of model management and device-specific hardware acceleration. Whether that is for CPU, GPU, or NPU, you don't need to write device-specific code. And then on the right is the Foundry Local CLI, so you can play around with models, see which best fits your scenario. All right, with that, I'm going to hand it to Anastasia. Tell us about Windows ML.
Yeah, thanks, Aditi. Now, those earlier scenarios, as you saw, were using ready-to-use AI models and APIs. But if you wanted to run your own custom model, for example, one that you trained yourself or maybe found on Hugging Face, that's where you would use Windows ML directly.
So what kind of devices can the coffee shop use to use Windows ML?
Yeah, well, the good news is Windows ML has really broad support, starting with Windows 10, 1809 and above, Windows Server 2019 and above, and even Windows 365 to provide a cloud-based Windows environment so that developers or potentially employees at the Unmetered Token Cafe can access their Windows ML development environment from any device. That can be another PC, a Mac, mobile device, or a browser. All right, so one scenario where Windows ML is going to be really helpful at the Unmetered Token Cafe is for their experimental Brews program, where the cafe rolls out new menu items to customers and then classifies sentiment for the reviews that come in to get a sense of how the menu item is doing. For this scenario, I'm going to be using a custom open source model, so Windows ML is going to be the perfect fit, allowing me to run the model locally and performantly through one unified stack that scales across all Windows devices. Now, for those of you that have spent some time in this space, you'll know that it's not actually always as simple as just taking a model and running it. Sometimes you'll need to spend some time optimizing your model. And depending on your scenario and your target hardware, that can be somewhat complex and time-consuming. For example, if your model doesn't export cleanly, or if some of your model operators aren't supported out of the box on your target hardware. And so to help with just that, we're really excited to announce the brand new Windows MLCLI, which is now available in preview for you to try out on GitHub, and it's intended to cater to all of your model optimization needs. So check it out at aka.ms/winmlcli. All right, so let's talk about what the Windows ML CLI provides. First off, it provides a one-stop toolchain and set of agent skills so that as a developer, you can take your model through conversion, optimization, and benchmarking through one flow. Next, the CLI is built to give developers maximum flexibility. You can use primitive commands to run each stage of the optimization pipeline yourself and have really hands-on control over exactly how that takes place, or you can keep things simple and run the whole thing end-to-end using a pre-built config. And third, the CLI is built to integrate with AI workflows and agents and provides a set of agent skills to make it really easy for you to get started and incorporate it into your AI-driven workflows. For example, using GitHub Copilot or your tooling of choice. And then for developers that prefer to get started with some UI, you can also check out the Foundry Toolkit extension in VS Code to get started. All right, so let's see this in action. We are going to be running the Windows ML CLI to optimize the model that we are going to be using to classify sentiment for new items at the cafe. And I'm going to be running this demo on a Surface laptop for business, 7th edition laptop with Intel processors. But it's important to note that the output of the CLI is actually going to be a portable model that I'm going to be able to run across all devices. So let's check it out. All right, so here I have a Python virtual environment with the CLI already running. So let me go ahead and type in the winml command. And what this is going to do is list out all of the commands that are available for me to try out through the CLI. Let me then go ahead and type in winml catalog. And this is going to list out just some of the models that are available for me to optimize through the Windows ML CLI. But as you can imagine, you can use it for many more models. For example, other models that you might find on Hugging Face, or your own model that you trained yourself and then converted to Onyx format. So Aditi, out of this list, is there any model that catches your eye that we can potentially use for this sentiment analysis scenario?
Yeah, is there one there called Cardiff NLP for sentiment?
Yeah, great eye. Okay, so the next thing that we would do is run the winml inspect command. Now, just for time, I've already pre-run this command, and I'm going to show you what the output is going to look like. And what this command does is it helps me rule out common reasons why a particular model might not be a good fit to optimize through the winml CLI before I spend too much time on it. In this case, I already ran this, the output is looking good, I don't see any errors, so I'm good to continue forward. the next thing that I would do is actually go ahead and export my model. This command I've also pre-run just for time, and I'm showing you here what the output looks like, and what this is going to do is essentially just convert the model to ONNX format, and then that's what we're going to use for the rest of the optimization workflow. Now that we've exported our model, let's go ahead and run the analyze command. And what this is going to do is read through my model graph, operator by operator, and see which of my model operators are supported on my target hardware. In this case, if I scroll up and take a look at what the output looks like for Qualcomm, I can see that a bunch of the operators here are showing in green. That's good. That means the operator is fully supported. For anything that's showing in yellow, that means it's partially supported, so it might fall back to CPU. And if I were to see anything in red, which I don't have here, that would mean that the operator isn't supported at all. So now that I've run this, the next thing that I would do is run the optimize command. And let me just resize this really quickly so that you can see me running that. So I'm running the optimize command, and this is going to take in the config file that the previous step generated to actually rewrite my model graph, fuse graph operators, and address any of those operators that weren't fully supported. So I just ran that, and that ran really quickly. So now let me rerun the analyze command, because I want to make sure that everything is showing up as green before I take next steps. All right, and as you can see, that's running. And now everything across the board is showing up as green, which is great.
Very nice.
So the last thing that I'm going to do here in the CLI is run this perf command. And this is going to help me benchmark my model. It's going to give me some stats about throughput and other indicators for me to have confidence that the model is ready for my production workflow. And here you can see we're getting a live graph showing NPU utilization. It's really high, so that's great. And my performance is looking pretty good as well. So I think I'm good to go ahead and move forward with this model.
Yeah, it was also super cool that everything you needed was available in one CLI tool.
That's right. And in this particular workflow, I ran each command by command, but I could have also used a pre-built config to run the whole thing end-to-end, or I could have used GitHub Copilot and had my agents do the model optimization flow for me. All right, so now that we've optimized our model, let's talk about how Windows ML is going to help us run it, and more broadly, how Windows ML can benefit you in running your own custom AI workloads across Windows GPUs, NPUs, and CPUs. First off, scale. Windows ML serves as an abstraction layer to make it easier for developers to scale their models across chipsets and hardware vendors without having to get as deep in hardware specifics or have to deal with several different SDKs. With ONNX runtime integration, Windows ML also provides a high degree of flexibility on what models can run and where. Next, performance. We're partnering with our Silicon partners to make sure that the latest performance improvements, innovation, support for new models and devices makes it into the stack through hardware vendor-owned execution providers. This way, you get like native benefits, but through one unified stack. And third, deployment. Windows ML provides a system-wide copy of runtime dependencies along with APIs to help you pull down the right bits based on your device. This way, you don't have to package those runtime dependencies with your app, can reduce your app size, and don't have to recompile your app every time an update takes place. And with our vendor certification program, the bits that are provided from Windows ML to app developers go through rigorous Windows-specific testing with every update. So regardless of how you're deploying Windows ML, you're getting the runtime dependencies that are optimized for stability, Windows maintained, and will help you have a smooth update process. And then one last thing to call out on this slide, Windows ML also provides a unified toolchain and set of agent skills, as we talked about, such as the Windows ML CLI and the Foundry Toolkit extension for VS Code to help developers prep and optimize their models.
So that sentiment analysis workflow, I wish it was possible to run that through a website so that anyone at the cafe could access it without having to download an app or without having to use the cloud.
Yeah, well, the good news is They can. Not only is Windows ML supported for your everyday native Windows app experiences, it's also supported for web apps through WebNN, which is available in preview with a few experimental flags in any Chromium-based browser such as Edge or Chrome. And you can think of WebNN as the layer that sits on top of native ML APIs like Windows ML on Windows, providing near-native access to GPUs, NPUs, and CPUs through framework APIs. And that means that even websites can benefit from native Windows ML-based hardware acceleration without racking up token costs or sending sensitive enterprise data to the cloud. All right, so let's see this in action. And I am once more going to be using the Surface Laptop for Business 7th edition laptop with Intel processors, but this time we're going to be inferencing the model. All right, so here I have VS Code open with my web app, and I have the sentiment analyzer.js file open, which is where the bulk of my inferencing code is going to be. Some of the key things to call out here is I'm using the Onyx Runtime Web APIs, which are framework APIs that I can use for running Onyx models in the browser, and under the hood, that's going to use WebNN, which is going to be working with Windows ML to get that native Windows ML-based hardware acceleration. I'm then going to go ahead and pass in the models that I optimized earlier through the Windows MLCLI, and then we're going to go ahead and create our inference session. And so to do that, I'm going to use the WebNN create context APIs here to set up my session, and I'm going to pass in a device type. Now, initially, this is set to NPU, but let's actually go ahead and change it to NPU because we're going to want this to work on all the devices at the cafe, not just Copilot plus PCs. So I've gone ahead and updated that to CPU, and then we'll set up our inference session by passing in that context here, the model data from earlier, as well as setting the name of our execution provider to WebNN. And then the rest of this file is just going to take care of things like model tokenization, tensorization, running inference, and then based off of the model outputs, classifying my sentiment as positive, neutral, or negative. All right, so let's see this running. I'm going to do a hard refresh here, and as you can see in the bottom right-hand corner, we're going to be running this on the CPU to classify sentiment for this decaf Eclipse beverage, which is a no-caffeine espresso. So let's see how that's going to do with the customers at the Unmetered Token Cafe. Okay, so this is now running, and as you can see, I'm getting that blip on the CPU because we're using the CPU on this device to classify sentiment for these reviews that are coming in. Nothing needs to go to the cloud. I'm getting latency of about 300 milliseconds and about 3.5 reviews getting classified per second. So not bad. And if I take a look at this live chart and the sentiment trend, this beverage isn't doing the best. A lot of neutral sentiment and negative and positive roughly equal. So maybe that was a little bit of a questionable choice. All right, so now let's go ahead and go back to VS Code, and we're going to update this to now run on the NPU because I also want to get a sense of what this is going to look like for the Copilot plus PCs at the cafe. So let's now go back and refresh this page. And just to make things more interesting, we're now going to classify sentiment for this Aurora Latte beverage, which is a lavender honey beverage with a gradient pour from violet to gold. And as you can see in the bottom right-hand corner, this is now going to be running on my device's NPU. So let's see how this does. All right. Right away, you can see blazing fast performance compared to what we saw on the CPU. I'm getting just 30 milliseconds of latency here, over 11 reviews being classified per second, so that's more than ×3 the reviews, the rate that we were seeing for CPUs. And this beverage is doing much better as well. That's great news. All right, a lot of positive sentiment, and negative is very low.
Yeah, I think I want to try one of these Aurora lattes.
For sure.
So this was a super cool demo, but is this ready for production?
Yeah, well, Windows ML went to general availability just last fall, and already there are dozens of partners shipping production experiences on Windows ML to general availability. Those include Adobe, Canva Affinity, Speechify, and many others. And speaking of that, we actually have a couple very special guests here. We have Jordi and Flex, who are from the Voicemod team, who have built a really compelling experience using Windows ML that's going to give you a sense of just how low latency Windows ML and local AI experiences can be. And they're going to be running their demo on a different device, on this device, which is an Asus ZenBook A16 laptop with a Qualcomm Snapdragon NPU. So Jordi and Flex, welcome and come on up.
Hi everyone, I'm Jordi, Head of Research and Innovation at Voicemod.
Hi everyone, my name is Flex. I'm a content creator and Voicemod ambassador.
We're a Windows-first platform that lets anyone transform your voice in real time through voice filters, soundboards, and creation tools.
Gamers and streamers customize everything. Their skins, their avatars, their setups, but their voice is still the one thing left untouched. That's where Voicemod comes in. So anyone can sound exactly the way they want to be heard online, whether in-game or in voice chats.
And Voicemod delivers a sophisticated audio generation pipeline by combining digital signal processing effects and cutting-edge generative AI speech-to-speech models. And to have a truly immersive experience, our AI models can operate at ultra-low latency, below 45 milliseconds, so that any voice interaction feels instantaneous and natural. And to do that at scale, we've been building on Windows ML. And Windows ML has allowed us to offload heavy AI inference computation from the CPU to NPUs and GPUs. And basically, to us, Windows ML offers three things. First, it has allowed to run higher quality models locally, so there's no cloud dependency. Second, it allows to reduce the app size thanks to the abstraction of the execution providers. And third, it allows us to deliver 4 times faster as we built it once, and then we could deploy across our silicon partners, Qualcomm, NVIDIA, AMD, and Intel. But to better understand how it works, I think the best we can do is to see it live. So Flex, would you like to show us the magic?
Absolutely, Jordi. We are going to give some spice to these Fortnite skins using Voicemod. So our first skin here is called the Ice King, and I want to give him a voice that is powerful, that is scary, that is commanding.
Maybe something like this. Maybe a skin like this needs a voice like this. Or a skin like this? I don't know. Let's try. Maybe this voice.
I think this one maybe fits a little bit better for this guy. Or actually, let's try this one.
I don't know. This might not be the right voice. What do you think, Jordi?
That's cool.
I agree, and I feel like everyone wouldn't mind grabbing a copy and sticking around for the rest of the stream, but alas, the show must go on.
Thanks, Microsoft Build, and thank you to the Windows ML team for making this possible. So.
Fantastic. Thank you, Jordi and Flex. Incredible demo, and great that Windows ML was able to help you scale your experience across more Windows devices. All right, so finally, let's take a look at all of what's new for Windows ML in 2026. First off, as we talked about, the Windows ML CLI is available for you to try out in preview on GitHub to optimize and prepare your models. If you're running generative AI experiences, for example, using LLMs or other generative workflows, you're going to see some performance speedups, so up to times 2.6 throughput for Gen AI workloads, depending on which model you're using. And if you're using the default CPU execution provider, you're going to see some performance speedups also with the newest version of Windows ML that's currently available in preview. Next, Windows ML 2.0 has shipped. That includes Onyx runtime improvements and support for new hardware vendor plugin execution providers, which across the two of those is going to mean support for new models, fundamentals improvements, and improved compatibility between releases. WebNN is also available for you to try out in preview, and that's how you can bring native hardware-based acceleration to your web apps as well in Chromium-based browsers through a few experimental flags. Then, because of how Windows ML works, all apps that are built using Windows ML also get to benefit from all of the innovation that's happening from across the entire silicon ecosystem. So from AMD, Intel, NVIDIA, and Qualcomm. For example, support for all the newest, latest, and greatest devices, like Ryzen AI 400 series processors from AMD, Intel Core Ultra Series 3 processors, the upcoming NVIDIA RTX Spark and DGX Station devices as well as Qualcomm Snapdragon X2 Elite processors. And those aren't the only things that are new, the new devices, although those are definitely very cool. There are also tons of other improvements, as you can see on the slide, ranging across fundamentals improvements, performance, tooling improvements, and so much more. All right, Aditi, we've covered a lot in this session. What are some of the takeaways that we should leave our audience with?
You're right, we did cover a ton of content, so let's bring it all home. Okay, through the narrative of this unmetered token cafe, we were able to show you how easy it is to get started building experiences with the AI APIs and how we've expanded many of those capabilities to now run on CPUs and GPUs. We showed how you can run common open source models locally with Foundry Local, and now Foundry Local is in GA. And then we showed how you can bring your own model with Windows ML and do complex optimizations with one CLI tool. And we are so excited to see what you all can build with Microsoft Foundry on Windows. So before you all leave, take out your phones. We have a ton of resources to help get you started. Take a photo of all of those links there. We also have other sessions, the app build, that might be relevant, that could help you get started as well. And then please scan that QR code. Provide us feedback on the session, on our product. We love to hear from you all. And then Anastasia and I will stick around in the lobby if you want to come talk to us, ask us questions. Thank you all so much.